Okay, so I'm gonna try to do this sort of quickly, so that the video doesn't take forever. So, answer key. Okay, so plot the line, connect all points with a straight line. Okay, so basically what I have here is I have a bunch of linear equations in slope-intercept form. Slope-intercept form, which is y equals mx plus b. Because this type of equation tells us the slope and the y-intercept. Okay, so basically what we need to do is we need to pick out what's our b, which is our y-intercept. We can do that for everything. Oh, this one, it's, since there's no plus b, it's like the y-intercept must be 0. And you obviously don't have to work through it in this order or something. I'm just like trying to emphasize like, okay, there's the b that we found out. So let's put that b down. So since the y-intercept, so the place where that line crosses the y-axis or the vertical axis is going to be +2. Here, I'm going to cross the vertical axis at -4. Here, I'm going to cross the vertical axis or the y-axis at 0. And here, I'm going to cross the vertical axis at -8. Okay, so that's kind of like literally half of the battle. So then here, so I can see my slope here is -5/7. I just like to give the negative to the top. I talk about that all the time, but I just like to give the negative to the top. When it's a negative out front, it doesn't change anything. It's just I personally think about it that way. Because slope is rise over run. So I know that my rise or my vertical change has to be -5 every time my run or my horizontal change is 7. So every time I go across 7, I have to go down 5. So when I go across 7, I have to go down 5. 1, 2, 3, 4, 5. I can just do another point too to help me draw my line better. So when I go across 7, because I'm going backwards now, if I go backwards 7, I have to go up 5. 1, 2, 3, 4, 5. And that gives me my linear equation, essentially. So if I connect all of these points, then everything is great. Because I can see that I cross at the y-intercept of 2, +2, and then every time I go across 1, 2, 3, 4, 5, 6, 7, I go down 1, 2, 3, 4, 5. Every time I go across 7, 1, 2, 3, 4, 5, 6, 7, I go down 5. 1, 2, 3, 4, 5, and that's how I get to that point. Okay, so, oh, I kind of covered this up. The slope is 2/3 here. 2/3. So a rise of 2, that would be +2 for every run of 3. So when I go across 3, I have to go up 2. Across 3, I want to go up 2. across 3, I want to go up 2. When I go back 3, I want to go down 2. Back 3, down 2. Back 3, down 2. So that's great. There's my little linear equation. I can connect my points with a straight line. Okay, so we're almost there. So we know it crosses here. So this slope, -2, it's like it's -2 over 1. Because we can always put, if we just have a number with no denominator, we know that that kind of denominator in air quotes has to be 1. So the rise and the run. So every time I go across 1, I have to go down 2. Here, I'll make it so that you can see better. But across 1, down 2, across 1, down 2, across 1, down 2, across 1, down 2. And like, you didn't even have to necessarily put in all of these points. I'm just like, for the sake of just explaining and having a good example, that's why I'm just kind of drawing in all these points. Okay, and then finally we have this slope is, so it's as if we have -1x minus 8. So the slope is -1, which means we have a -1 over 1. We have a rise of -1, so that means we're going to go down in the y direction, in the vertical direction, every time we go across 1. I don't really have to keep drawing all of these points, but I guess I'm almost there anyways. Okay, there we go. That's page 1. So that's what we do. We're just looking for our y equals mx plus b. What's my slope? What's my y-intercept? Okay. Second page. So this says 2 points are provided. Plot the 2 points and connect them with a straight line. So let's just do that first. So remember, ordered pairs are an x comma y. X comma y. We can kind of basically be like, oh, this is x1, y1, x2, y2. So I want to go -4 in the x direction and -7. So that's one of my points. -4 comma -7, -4 comma -7, and then -2 comma -8, -2 comma -8. Okay, so you know what? Let's just keep going because it's so clear at this point. Like, we can already see if I connect these. If I were to connect these, I just want to connect them in a way where I don't mess up my drawing for later. If I connect these, I can already see, if I figure out the slope graphically, I can already see there's a run of 2. See how I'm going 2 across? So between these 2 points, we went across 2 units, down 1 unit. So if slope, or m, is rise over run, going down 1 unit is -1. Going across 2 units is 2. So that's my slope. And I could have used my slope formula, y2 minus y1 over which is actually on the front page. Like it's from the front page. And I would have gotten the same thing because I would see -8 minus -7 over -2 minus -4 equals -8 plus 7 minus minus becomes plus, minus minus becomes plus, and we get -1 over 2. So I definitely know my slope is -1. Here, I always like to, again, I've already said it in this video, but I always like to put the negative on the top. At the end of the day, though, it's like it's -1/2. So the y-intercept, so we kind of have to think about this. Well, this is my y-axis. Why don't I just get a red pen? This is my y-axis. And I can see my line doesn't actually really cross there right now, but I know that it would continue with the same slope. It would continue going across 2 and down 1. So, to be honest, you can just visually see the y-intercept has to be 9, like as in -9, sorry. And so that would be 0, -9. Coordinates are x, y. So I want to give the x coordinate and the y coordinate. And this line, the y-axis, the equation of the y-axis is x equals 0, because x equals 0 at every point. So we could have also done that algebraically. It's kind of the difference between graphically and algebraically. Algebraically, we would have gone, okay, we know y equals mx plus b. So therefore, b equals y minus mx. B equals, for this y and this x, I just take either of my points. We've discussed this in class a lot of times, which is great. I have to plug in my slope times the x value, which was -2, -8 minus 1. B equals -9. So that confirms what I already know. So this actually tells me my equation, because y equals mx plus b. Well, that's just y equals, instead of the m, I want to actually put in what it was that I calculated for m, which is -1 over 2x, because I leave my x the same, and then my b, which my b was -9, the y-intercept, so -9. So that's that. X-intercept. So this is the x-axis, this blue line here. And at every point along that line, y equals 0. So for the x-intercept, we want to figure out what the x value will be when y equals 0. So we take our little equation, y equals -1 over 2x minus 9. we plug in, instead of y, I'm actually going to replace that with 0. I'm replacing y with 0. So 0 equals negative. And then now I'm doing algebra. There's two sides of my equation. I want to get the x term by itself, so I have to add 9 to both sides. 9 equals, to get rid of this fraction, I can times both sides by the denominator, times 2. And then if 18 equals negative 1x, I can divide both sides by negative 1. X equals negative 1. Oh, sorry, x equals negative 18. And that technically should be correct. I'm just going to check on Desmos, just because I want the video to be helpful and not full of errors. Yeah, it is. When x is negative 18, y will be 0, and that means it will be. So basically, like, you can kind of imagine it's gonna be like off the page, which is totally okay, because that's why doing things algebraically can be amazing. You don't necessarily need to see the graph, because it's going to be off the page over here when it crosses that. If we can see, okay, if my line is continuing, it needs to be down here, kind of down here where it'll cross the x-axis. Okay, so I kind of took a long time explaining that one. Let's just really concise. Let's just do this. Okay, so negative 4, negative 4, negative 2, negative 1. Okay, my slope is, okay, negative 4, negative 4, negative 2, negative 1. I'm going up 3 for every 2. So I go up 3 every time I go across 2. That means I'm going to cross my y-axis at 2, 0, 2. So my equation is going to be y equals 3 over 2x plus 2. Find the x-intercept, set y equals 0, and solve for x. 0 equals 3 over 2x minus 2, 3 over 2x. Negative 4 over 3. Does that make sense? So, 2. Yeah. Okay, let's just check on Desmos again. Yep. Negative 4 over 3. Yeah, we're good. Okay. So, oh, and I actually forgot to, because yes, the x value is going to be this for the x-intercept, but just remember, so that's our x value when y is 0. Same thing up here. The x value was, wait, where am I? The x value is -18 when y is 0. So just remembering to just be aware of how these are actual coordinates. Okay, if that's that, I guess I should connect my line. 2, 3, 2, 3. I just want to like have a good line, you know what I mean? A nice, neat little linear equation. So there we go. Nice. Okay, that was everything. I think that was everything on that page. Okay, so this is just like a lot of the same. So basically what we're gonna do is slope equals y2 minus y1 over x2 minus x1. All of these we have like an x1, y1, x2, y2, x1, y1, x2, y2, x1, y1, x2, y2, x1, y1, x2, y2. So it's literally the same as the other page, but just algebraically. So oh, whoops. This simplifies to, here, I'll just show myself simplifying it. Divide by 2, divide by 2, -3 over 5. So slope is -3 over 5. I can solve for my y-intercept. B equals y minus mx. I pick either point, and that gives me my x and my y. So -8 minus 3 over 5 times 20, -8 minus, it's going to be 12, I think. Just check. Yeah. -8 plus 12, 4. B equals 4. So that means my y-intercept is going to be 0, 4. That means my equation is going to be y equals -3 over 5x plus 4. Because I just plug in my slope and my y-intercept. Let's just double check that everything's going okay. Yeah, looks good. Okay, so then just briefly, then we would find the x-int, which is where we always replace y with 0. Solve for x. So I have my equation. Instead of y, I put my 0. Okay, so x equals -20 over -3. But if it's a negative over a negative, That's a positive. Just because there's no point in doing a negative over a negative, it doesn't really, we know that positive times positive gives positive, positive times negative gives negative, negative times positive gives negative, negative times negative gives positive, and the same rules for division. Since the fraction line is division, if it's a negative over a negative, it's just positive. Okay, I think we should just stop there because school's gonna start anyways, and to be honest, like, these are exactly the same as this process. So if you're trying to understand, trying these out would be good. I'll upload the actual scanned answer key anyways, so I just don't think we need to go through it right now. Okay, that's it.